Hello and welcome to 11.4 Graphing Polar Coordinate Equations. So today we'll be looking at trying to graph some of these equations. I won't go through all of them, but some of the more common ones. Okay, we start off with circles. We'll start off with the most basic circles. You guys will remember that in our previous lesson we talked about when r equals something like 2. Right? When r equals 2, it's a radius of 2, so we know that we'll have a circle centered at the origin, right? And it'll be a radius of 2 all the way around. Okay, same thing actually works if we have r equal to -2, right? So -2, you would have to take the absolute value basically, and you end up with the same circle. Okay, so let's take a look at some other types of circles that are not centered on the origin. And those would be of the type that are r equals to a cosine theta, and another version of the similar circle would be r equal to a sine theta. Okay, so the way that works is a is your diameter, and then cosine you'll associate with the x-axis, sine you'll associate with the y-axis. Okay, so let me show you guys how that works. So if we said, let's say r equals 6 cosine theta, your circle will be based off of it'll be sitting on the x-axis. Okay, and you'll have a diameter of 6. Okay, so you'll always start off with these types of circles. One of the endpoints will be on the origin, and then you'll count 6 in the direction of the x-axis. So you'll have, say, 6 is here. Okay, so that means your center would be at 3, 0, and then you could count up 3, count down 3. So you'll have a circle that looks like this. Not a perfect circle, but you get the idea. Okay, let's do another quick example. If we had r equal to -6 cosine theta, now that implies that we'll be on the negative side of the x-axis. So our diameter would reach as far as -6. Okay, and our center will be at -3, 0. And we count up 3, we count down 3. So our circle will be like so. Okay, so positive a cosine theta, you'll be on the right side. Negative a cosine theta, you'll be on the left side. Okay, and a, absolute value a, gives you the diameter, right? Okay, let's do r equals a sine theta. So let's say we had r equals 4 sine theta. So now these circles will be sitting off of the y-axis. Okay, so you'll have uh, 4, so you'll go 4 in the positive y direction. So that means diameter is 4. And so that means the center here will be at 0, 2, and then you'll go 2 units in either direction. So you'll have a circle that looks more or less like this. Okay, r equals negative sine, -4 sine theta. Again, you'll have your coordinate plane, and so your diameter will go down, reach down to -4. That means your center will be at 0, -2. And you'll have a circle. Okay, something like that. Okay, so those are our circles. Let's take a look at our next family of shapes. These have several names depending on the values. Okay, so in general we have these in this form: r equals a plus or minus b, and you could have two versions of this: a plus or minus b cosine theta, and then r equals a plus or minus b sine theta. So let's look back at our table on the opening slide. So here what we're talking about are these three shapes here. We got the cardioid, limosone, one loop, and inner loop limosone. Okay, so you'll notice their equations are all of the same variety. The only difference is how the A and the B's are numbered, right? So let's take a look at one of these. We have our first one, let's say, is r equals 3 plus 3 cosine theta. Okay, so when we go to graph this, now because the cosine, this is going to be, I like to think of these as, let's go back to the, I like to think of these as fruits. Right? You can think of like it's a peach or some, I tend to think of it as some kind of fruit shape. So the peach, in this case, is going to be lying off of the x-axis. Okay, it'll be, if you reflect over the x-axis, it's going to be identical shape. Okay, so it's basically sitting right on the x-axis or the polar axis. Right. So for this is called the cardioid. The cardioid happens when you have this ratio here of a and b equal to 1. So if you do the ratio of a over b equals 1, it results in this cardioid. Okay, so let's see how that works. So I got my 3 and my 3. I do the ratio. I see it's equal to 1, so it's going to result in that type of shape. So the bulk of this shape, because it's a plus 3 cosine theta, the bulk of the shape will be on the right side of the polar axis. Right? It's on the right side. The fruit's going to be sitting on the right. Now, the way we end up getting our endpoints, there's some key endpoints here. You then take the A and the B, absolute value, you're going to add them up. 3 plus 3 is 6. Okay, so you're going to go out to 6 and you make your point. Okay, then the first 3, this is going to give you your intercepts for the opposite axis. So this will be like the y-intercept. So you'll have a point at 0, 3, and that many units you go the opposite way, -3. And then there's a fourth point, and what you do is you subtract a minus b. So you do 3 minus 3, 0, and that 0 goes there. Okay, so the way the graph would work is you'd have something like this, and you trace it around. Okay, so you end up with your cardioid. And the shape name is from, cardioid, like a heart, right? It'll look like a heart shape. Okay. So let's say we had a different version of this. Let's say we had r equal to 3 minus 3 cosine theta. So here we have a similar idea. A and B ratio is 1. Okay. Now because there's a negative in front of the cosine, this is going to be sitting on the negative side. So it'll be sitting on the left here. You're going to add the 3 and the 3, take absolute value of A and the B, add it together. So you're going to go out to 6, going to the left. 1, 2, 3, 4, 5, 6. Okay, you'll put a point. Again, this 3 will tell you the intercepts of the opposite axis. So you'll go 1, 2, 3, 1, 2, 3. Subtract a minus b, so 3 minus 3 is 0. Let's take absolute value of 3 minus absolute value of 3, so 0. So you have a shape okay, it would look like that. And I would recommend, as you guys are practicing this, to just piggyback off of Desmos so you get a good sense, just type it in just like this, r equals, and then you get a sense of what it looks like. Okay, let's do similar cardioids with sine. Okay, so let's say we had r equals 2 plus 2 sine theta. Okay, so now this will be based off of the y-axis. So you're going to add 2 plus 2, that'll be 4. So you're going to go out 4 units. The first 2 will tell you the intercepts on the opposite axis. So it'll be on the x-axis. I mean, these are polar coordinates, but still, if you want to think x and y. And then 2 minus 2 is 0. So you'll have a 0. So your cardioid will look like this. Okay. Similar thing if you had 2 minus 2 sine theta, then you have the cardioid. The minus 2 would imply it's hanging below on the negative side of the y-axis. Okay, again, you take the absolute value, go down to -4. The first 2 tells you the intercepts, and then 2 minus 2 is 0. Okay, it'll look like that. Okay, any questions, let me know. Now you might ask yourselves, well, what if we end up with r equals -2 minus 2 sine theta? Right, like what if the first one was negative? Okay, well, let's think about this in terms of functions. If we pulled out a negative, what does this look like? So if we have -1, we have 2 plus 2 sine theta. Right? So if we think about 2 plus 2 sine theta, that's this one on the left. But now if we have a negative in front of it, that means we're going to flip it down. Okay, so this one ends up actually looking like the one on the right. Okay, so just something to keep in mind. Okay, so the function rules can still help you, navigate through some of these questions. Okay, all right. Okay, this next one we're just going to look at it as a one-loop limosone. So let me go back to the table. The one-loop limosone, you'll have the ratio of A over B equal to something between 1 and 2. Okay, so as long as it's a ratio of A and B between 1 and 2, it's going to look not exactly like the one in here in the diagram, but it'll have a more flattened shape on one side, and I'll show you guys what that looks like. Okay, so let's go. Yeah, so just keep in mind the ratio of A over B is between 1 and 2. Something like, let's say this, we have R equal to 5 plus 3 sine theta. Okay, so the way this works is this will be based off of sine, so sine is based off of the y-axis. Okay, so your fruit will be sitting on the y. You're going to add the 5 and the 3, so that'll give you how far up it's going to go. So it's 8. Okay, so it's going to go up to 8. For your points along the opposite axis, that's the 5. So same rules apply. So you have 5 this way, 5 the other way. And then for that point in the middle that we often draw, we subtract the 5 and the 3. So 5 minus 3 is 2. So that means we're going to go 2 units down. And that's where the third point will go, or the fourth point will go. So we'll have something like this. Okay, something along those lines. Okay, well that's how it would work. Okay. Obviously, if we have 5 minus 3 sine theta, then this whole thing will be flipped. It'll go upside down, and you'll have upside down one loop limosone. Okay, let's do one like this, 5 plus 3 cosine theta. So we'll have our graph. The fruit will be sitting off of the x-axis because of cosine. Okay, 5 plus 3 will give us 8. So we go 8 deep going to the right. There's 1 point. 5 will be the intercepts on the opposite axis. So 5 and negative 5. And then subtract 5 and 3, we get 2. So you're going to go 2 units this way. So you'll have something like that. Okay. And obviously if you had 5 minus 3 cosine theta, you flip this across and you'll have a shape that flips the opposite way, as if you're flipping it across the y-axis. Okay. All right, let's take a look at some other, the inner loop limosone. Okay, inner loop limosone happens. Let's take a look here. As long as A is less than B. If A is less than B, we get an inner loop limosone. Okay, so let's take a look at an example like that. So if we have, let's say, R equals 3 plus 5 sine theta. Okay, so if that's the case, then we have A is less than B. right? 3 is less than 5, so we have an inner loop. That means, now again, because it's off of based off of sine, we add the 3 and the 5, that gives us 8. So we'll have 8, and then 3 is our opposite axis. We're going to do the intercepts, so 3 this way and 3 this way. And now we do is subtract 3 and 5. So 3 minus 5 is negative 2. So instead of projecting outwards this way, 3 minus 5, negative 2, we're going to project inwards. 1, 2, negative 2. Okay, so you're going to get a shape, and you'll have, it'll go like this, it'll go like this, it'll go like that, and it'll go like that. So that'll be the inner loop limosome. Okay. All right, and then if we do, let's do R equals 3 plus 5 cosine theta. Okay, so the fruit will be sitting off of the x-axis, positive side. So again, we go to 8. 3 would be the opposite intercepts. 3 minus 5 is negative 2, so we go to negative 2. So this will be a shape that looks like this. Like that. All right, any questions, just bring it up during the lecture or email me. Okay, next let's take a look at the next shape. These are like the rose petals, we call them. Rose curves in this table. So these are like these two we have here, rose curves. So with these, you'll often see the equation look like R equal to, and then we have some number, and then we would have cosine of n pi, and then you could have R equals some number times sine of n pi. Okay, so the idea here is if n is odd, you get n number of petals on the flower. If n is even, then you get 2n number of petals. Okay, so that's the key thing to remember here. Okay, so now sometimes we have to do a little calculation because the positioning of the petals is important. Okay, the positioning of the petals is very important. It helps to produce the accurate graph. Okay, so let's say we had, let's do a few examples. Let's say we had R equal to 3 cosine of 5 theta. Okay, so here, the 3 is going to tell us how long the pedal is going to be. So that means each pedal is going to be 3 R's long. Okay, so 3 units long. Now we had how to position the pedals. We have to do something with the 5 theta. Okay. So normally when we do the graph, let's think in terms of theta. And this is important. When we think in terms of theta, our theta is between 0 and 2 pi. Correct? Okay, so when we're doing the adjusted graph for this, now we have to adjust because now we have 5 theta, right? Whatever theta we have, we're multiplying by 5. Okay, so if we think about that, so now we're going to be going, if we multiply by 5, this whole thing, 5 times 2 theta would be 10 theta. Or 10 pi, I should say. 5 times 2 pi would be 10 pi. Okay. So, what does that mean? Well, first of all, where do we end up with a maximum value for this angle? Right? Because that maximum value, that'll give us the endpoints. For example, we know cosine of 0 is 1. Right? We know cosine fluctuates between -1 and 1. So we want to find out where cosine is 1. Right? So cosine is 1 at 0. So we know that at 0, when theta is 0, we would have cosine of 1, right? Cosine of 0 equals 1. Okay, so now, based off of this new theta, 5 theta, that means, okay, I could have theta being 0 again, right? Okay, so now next, to get my other maximum points, okay, because keep in mind, I have 5 theta, right? So that means I'm expecting how many pedals? N is 5, so I'm expecting 5 pedals. So that means I'm expecting 5 places where we're going to get a maximum value to get the edge of those pedals. Okay, so for the first one, we say 5 theta is equal to 0, so theta is 0, right? Now, the next step, we're looking at all the cases here. Theta would be a maximum at 2 pi, right? It would be a maximum at 0. Now, because we're going to go for 5 pi, for 5 theta, we're going to go between 0 and 10 pi. That means that we would have, let me adjust this. So we're basically going to say, okay, 5 theta is equal to 0. 5 theta is equal to, and go in increments of 2 pi. 2 pi. 5 theta is going to equal 4 pi, because that's the next time after that, right? Just wrap around one more, 360. 5 theta is going to equal 6 pi. 5 theta is going to equal 8 pi. And then once we get to 10 pi, that's the same as if we're back to 0 again, right? Just like when we get to 2 pi, we're back to 0 again. So we don't need to do the 10 pi. Okay? So Let's now figure out the thetas for all these. Well, if we divide by 5 here, we get theta of 0. If we divide by 5 here, we get theta equals 2 pi over 5. Theta here would be 4 pi over 5. Theta here would be 6 pi over 5. And then theta here would be 8 pi over 5. Okay, so that means that in each of these instances, at these thetas, we're going to get a maximum value. Right? Okay, so if you're having trouble picturing this, we could do a quick table, theta and r. Right, theta is, let me just go off of these numbers here, we have 0, 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5. So if you plug this in into our equation, r equals 3 cosine of 5 theta. So if we plug in 0, cosine of 0 is 1. 3 times 1 is 3. Now, we have 3 cosine of 5 times 2 pi over 5. Cancel out the 5's. Cosine of 2 pi is 1. 3 times 1 is 3. Okay. 3 cosine of 5 times 4 theta over 5. Again, you cancel out the 5's. Cosine of 4 pi is 1. 3 times 1 is 3. So you get the idea here. You'll do the same thing. 3 cosine of 5 times 6 pi over 5. Cancel out the 5's. Cosine of 6 pi is 1. 3 times 1 is 3. Same thing for that one. Okay, so how do we graph this then? Okay, so for each of these angles, now you're going to estimate. Okay, 0, you know where 0 is, right? So at 0, go 3 out, there's going to be one of your petals. 2 pi over 5, 2/5 pi, so that's what, a little less than half pi, right? 0.4 is 2/5. So pi over 2 would be at the 90, so this petal would probably be about like around here. Okay, 4 pi over 5, 4/5 pi, so that's not quite enough pi yet. So 4/5 pi will be not quite at here, but it'll be like right around here probably. Okay, 6 pi over 5, 6/5 pi, so that's going to be a little bit past the pi mark. Okay, probably around here. And then 8/5 pi, okay, 8/5 pi, that's going to be probably right around here. 8/5 is greater than 3/2, right? Because I'm thinking 3 pi over 2 down here. 8/5. Yeah, so that would be right around here. Okay, and then you'll do your petals. Petals will go like this. Okay, and then you'll have your graph for your function. Okay, so that's r equals 3 cosine 5 theta. Okay, let's do a similar one. R equals 3 sine 5 theta. Okay, so when we do this problem, again, we want to figure out where our angle is going to reach our maximum. Now remember, sine of pi over 2 is 1, right? So when sine is 90, we get 1. Okay, so now we have to adjust, and we have to think, okay, because theta is normally between 0 and 2 pi, 5 theta would be between 0 and 10 pi. Okay, so that means we have to adjust our 5 theta, set it equal to pi over 2. That means theta will equal pi over 10. Okay. Now we add 2 pi to this, pi over 2. So pi over 2 plus 2 pi, or plus 4 pi over 2, that would give us 5 pi over 2. And that means to get theta, we divide by 5, so theta would equal 5 pi over 10, which reduces to pi over 2. Okay. Okay, 5 theta. Add another 4 pi over 2 to this one, so that would give us 9 pi over 2. And if we divide by 5, theta will equal 9 pi over 10. Okay, so 5 theta equal, add another 4 pi over 2 to this, so that would give us 13 pi over 2. Divide by 5, so theta would equal 13 pi over 10. And then add another 4 pi over 2, so 5 theta equals 17 pi over 2. Divide by 5, so theta would equal 17 pi over 10. Okay, so the maximums will occur at these angles here. Okay. So when we go to graph this, let's graph it. Okay. Again, the 3 is going to tell us how far deep we go. So it means 3 units. Now the theta is pi over 10. Okay, pi over 10 is going to be a little bit above our x-axis, if you will. We all know where pi over 2 is, so that's a good reference angle to start with. So if you want to start there. So there's our pi over 2. There's our first pedal. Okay. Let's go back and fill in pi over 10. So that'll be slightly above our x-axis. Nine pi over 10. So that's not quite a full pi yet. So that's going to be a little bit. So full pi would be exactly here. So this will be a little bit above. Like that. 13 pi over 10. That's going to be in this third quadrant. Here, and 17 pi over 10. Okay, that'll be like so. Okay, one thing to note, if we had r equals negative 3 sine 5 theta, then that would flip this. So that means then this top pedal would come down here where the 2 cent, and this will just be flipped upside down. Okay, going back to the previous problem with the 3 cosine 5 theta, if we had r equals -3 cosine 5 theta, then this pedal that started us off with the 0, that would flip to the other side. This will flip over the y-axis, if you will. Okay. So that's it for today's lesson. We did a bunch of these. You could practice with some of these other ones. Okay, there's also lemniscate, there's also Archimedes spiral. Okay, there's a lot of these. You just got to practice with them until you get better at them. Okay, any questions, just bring it up during the lecture or email it to me, and I'll be happy to help you out. Okay, have a good day, have a good night. We'll see you soon.